In this next video, we are going to go over 3 more definitions, all branching off of our first definition. So our first definition we're going to learn is adjacent angles. Think of adjacent angles as 2 angles touching. So if 2 angles were touching, they would have a common vertex. They would also have a common side. But they do not share interior points. So, 1 common vertex, 1 common side, and they do not share any interior points. That would look like, let's draw 1 angle, and we'll name this R, S, Q, and they need to share common vertex, so there's 1 vertex S, and let's make the common side SQ. So we'll have another ray branching off, ST, so angle RSQ and angle QST are adjacent angles. The interior points for RSQ fall over here, whereas the interior points for QST fall over here. So they do not share any of their interior points. However, they have a common side, which is this side, SQ, and a common vertex, which is S. From that, we're going to look at vertical angles. So vertical angles are 2 angles formed by intersecting lines, but those angles are not adjacent. So I'm going to draw 1 line, and I'm going to draw 1 more line that intersects. Intersecting means that it crosses, and they share a common point. So I'm going to name this angle A, this angle B, this angle C, and this angle D. Now, we're looking for 2 angles that are formed by intersecting lines but are not adjacent. A and B are adjacent angles because they share this common vertex, which is the center point. Let's just call that X for now. So they share this common center point, or vertex X, and they share a common side. So A and B are adjacent. B and C are also adjacent because they share the common vertex X, and they share this side. C and D are adjacent because they share vertex X and a side. And D and A are adjacent because they share X and the side. So we're looking for 2 non-adjacent angles. That would be A and C. A and C share a common vertex, but they do not share any common side. Therefore, they do not fit the constituents for being adjacent. They are not adjacent, and they're formed by intersecting lines. So if this was line 1 and line 2. D and B are also vertical angles because B and D share a common vertex, but they do not share a common line. Therefore, they are not adjacent. So B and D would also be vertical angles. So, angle A and angle C are vertical angles, as well as angle B and angle D. So those are 2 pairs of vertical angles. Also, if you notice, B and D are congruent angles, and A and C are congruent angles. That is because no matter how I cross that line, line number 1, one of the angles is simply going to be rotated to the other side. So it's almost like a reverse reflection. You can see as I move the ruler, angle A and C are getting smaller, while angle B and D would get larger. Or the other way, B and D would get smaller as A and C would get larger. Let's look at one more definition. So, a linear pair is simply two adjacent angles formed by opposite rays, where those opposite rays are the non-common side. What this is saying is if I were to draw an opposite ray, then there is one common side that the angles share to become adjacent. So we're looking at angle A and angle B. Angles A and B are adjacent because one, they share a common vertex. Let's go ahead and name that common vertex Z. And they have a common side. So A and B are adjacent. But they're a linear pair because the other side that A and B do not have in common form opposite rays. If instead I were to draw the line like this, A and B are still adjacent, but they are no longer a linear pair because they do not have two non-common sides that form the opposite ray. So these two sides need to form that opposite ray. So in this case, A and B are not linear pairs. So again, the angles need to be adjacent and the non-common sides have to be the opposite rays. In this video we went over adjacent angles and what makes angles adjacent. We went over vertical angles, showing that it's made up of two intersecting lines, but the angles are non-adjacent. And we went over a linear pair, which is a special case of adjacent angles. It's where the adjacent angles are formed from opposite rays.